Hello everybody, how we doing? We are back with another math video, and today we're going to continue on with our geometry series. Hopefully you've had the chance to check out some of the past videos I have put up. But we are talking about different shapes, different polygons. We talked about area, we talked about perimeter. We are moving into some specific shapes now. And this video is all about triangles, those special little three-sided shapes that we see all over the place. Now, up on top, we see three different types of triangles. Three different colors, three different shapes. Color does not matter as much. The shape is what matters, and especially the sides. So, the first one we're going to look at is right here, this blue one. Okay? This blue triangle has, and we're going to bring back those lines that I was telling you about before. It has 1, 2, 3 lengths that are all the same. Okay, remember, those dashes that are on the sides mean that anything with that dash is that same length. So that one, and that one all have that dash, even if it's not drawn perfectly. Okay, we're going to assume all three of those have the same length sides. They are congruent. Okay, congruent meaning the same. So what kind of triangle is that? Well, I'm glad you asked. That triangle right there is called an equilateral triangle. Okay? That is an equilateral triangle. Now, that equilateral is a big word, but just like that word quadrilateral we talked about the other day, once you break down its parts, it's not too hard to understand. We've got two main parts here. Okay, we got the equa, and we have the lateral. Okay, that I is part of it. Okay, so we talked about lateral, okay, meaning side. Okay, side or sides. Okay, that was the same in quadrilateral. Okay, quadrilateral meant that we had quad, meaning four, lateral meaning side or sides. So a quadrilateral, which we'll talk about in the next video, a bunch of different or more kinds of quadrilaterals, meant it was a four-sided polygon, a four-sided shape. This one starts off with equa. Now, back when we were talking about, it was either addition or subtraction, okay, we had that word that started off with an equa as well. And we decided that that word equa, or that little root equa, meant equal or the same. And we'll move that over so you can see what I mean there. So we decided that meant equal or the same. So if we break that down, equa meaning equal or the same, and lateral meaning side or sides, all that big word equilateral means is that it has equal sides, or same sides, same length sides. Okay, so breaking it down into the roots makes it a lot easier to understand. So that's an equilateral triangle. All three sides are the same length. We move to this guy in the middle here. This one has those two are the same length, and then this one down here is a different length. Okay, so all triangles, obviously, tri meaning three, and angles or corners. Okay, three sides. Only two of them are the same in this yellow one. This one has a special name, and I'm going to look down below because I always spell this one wrong. This is an isosceles triangle. Now, this one may have some roots that I'm not sure about, but one of the easiest ways, and probably the easiest way that I have ever heard to remember that this is an isosceles triangle with two sides of the same length, is something that I learned way back in the Stone Age when I was in 6th grade. We were talking about triangles. And my math teacher at the time, and I will call her out, Mrs. Elias, she told us that the way that she remembers an isosceles triangle is to say, I saw some leaves and two of them were the same. I'm smiling as I say that because it sounds so funny, but it sticks with you. It has stuck with me for the last however many years since I was in 6th grade. Isosceles sounds like I saw some leaves. Okay? And two of them were the same. Isosceles triangle, two sides are the same length and the other one's not. I saw some leaves, and two of them were the same. That's a good way to remember isosceles triangle as I move the paper. Okay. Now, if you have other ways that you can remember each one of these, feel free to use them. Okay. That one might just sound dumb to you and you might not like it. You might have an easier way to remember isosceles. You might have an easy way to remember equilateral other than breaking down the roots. Okay. Whatever way works for you. Same thing with this last one over here. This one is called a scalene triangle. And this one has no sides that are the same length. We've got that one, we got that one, and we've got that one. All three sides have a different number of dashes, meaning that all three sides are different lengths. Okay, this one over here, we put a single dash in those two sides that are the same, two in the one that's different. Over here, we got three that are different. Scalene, I don't know how you want to remember that. Just off the top of my head, the first thing that comes to mind is like a bathroom scale. You could say, you know, everybody that steps on a scale has a different weight. Something like that. I don't know. Like I said with this one, any of these, feel free. Come up with your own method of remembering those. Normally, it's kind of the dumb ones that are going to stick with you. But whatever works for you, that's the important thing. Whatever is going to help you remember what each one of these three is. But equilateral, all three sides are the same length. Isosceles, two of them are the same length. One is different. And scalene, all three sides are different. They all three have different lengths. Okay. Equilateral, isosceles, scalene. Now the one other thing that we need to talk about before we do some of the practice problems here. Angle. I've used that word a lot. And it might be a word that you've talked about before. That's great. But just in case, put very, very basically, an angle is how you measure the space between where a pair of lines meet up. Okay, so if we're looking at it here, right here is an angle, okay, where these two sides meet. That is an angle up here, where those two lines meet. Right here is an angle where those two sides meet. Okay. Same here. There's an angle. There are angles right there. I put those two lines on there for a reason. We'll talk about that in a future video. All of these, okay, wherever two lines meet at a point, there's an angle there. There's also an angle on the outside, which we're not going to talk about right now either. But that is an angle. When I'm talking about an angle, that's this little space in here where the two lines are meeting at that point. Okay. We're going to do some practice problems on the next page that have to do with that. That's why I really want to talk about that. But down here, let's start taking a look at these problems. Okay, we've got 4 different triangles. We need to fill in the blanks. So we need to call each one of these an equilateral, an isosceles, or a scalene based on what we know from up above. So number 1, none of the sides of the triangle are the same length. So we think back, which one of these did we decide had all different lengths? Well, it's not that one because we know all 3 of them are the same length. Isosceles, 2 of them are. Scalene is the one that doesn't have any sides the same length. So we are going to go in here and write scalene on our line. Scalene triangle. Number 2, all of the sides of the triangle are equal. Well, that one we know right off the bat is an equilateral. They even use that word equal, which helps us to remember equilateral. Okay? Equal sides, same length sides. Number 3, all of the angles are equal. Once again, we brought back that word angle. If you look at this one, we go back to our drawings, I put one little loop in each one of these corners. That's just like these dashes, except in angles, we just draw little loops from one side of the shape to the other side where that angle is, like right here, right here, right here. This one right here, equilateral, has 3 sides that are the same length, which also tells me these angles are going to be the same size as well. The distance between this line and this line, this line, this line, this line, this line, are all the same length. Over here, The reason I did 2 loops here, 2 loops here, and 1 there is because these 2 down here are the same. And again, we'll talk about that in a future video. But this one, you can tell just by looking at it, is a smaller space than these 2. But these 2 right across from the lines that are the same are going to be the same angle as well, which is kind of cool. Over here is something we'll talk about later on as well. I'll draw a little square in there. You'll find out why later. But again, this line or this side is different than this side, is different from this side, which tells me all 3 angles are going to be different. So we'll go back to number 3 and we look at that one. All of the angles are equal. Once again, that tells me it is an equilateral. And then number 4, 2 of the sides of this triangle are the same length. Well, I saw some leaves and 2 of them were the same. It is an isosceles triangle right there. Hopefully that's making sense so far. Okay. So we're naming triangles. However, that's not all we're going to do. We're going to label a few more of these as either equilateral, isosceles, or scalene. Then we're going to talk angles a little bit more. So let's take a look at 1 through 6. And I'm going to pause here for just a moment. If you would like to pause yourself and take a shot at these before we go through them, feel free to do so right now. And if you did pause, let's go ahead and go through these. Hopefully you took the chance to go through and look at them yourself. Now, they don't give us our lines, but just by looking at these pictures, we can pretty much tell what kind they are. I'm going to draw the dashes in for us. Number 1, we're going to assume that that one, and that one are all the same length. All 3 sides being the same length, they're all equal, means that one is an equilateral. Same length sides. Number 2, we have a dash there, a dash there. I'll put 2 dashes down there. That tells me 2 sides are the same. 2 sides tells me it's an isosceles triangle. Number 3, doesn't look like any of these are the same length, which tells me that one is our 3rd type, a scalene triangle. Number 4, looks like that one and that one are the same length, and that one down there is a little bit longer. 2 sides are the same, tells me it is again an isosceles. Number 5 looks kind of similar to 3 except just flipped around. Looks like that one, and that one are all different lengths, which tells me that is a scalene. And then number 6 looks like, once again, all 3 are the same length, which tells me that is an equilateral triangle. So hopefully you took the time to go through those during that pause, and hopefully you got all 6 right. Those are the answers to all 6 of those. But now, we're going to change things up just a little bit here. Okay? We've got a couple new words we're going to introduce to you. So we're going to label each one of these 6 triangles based on the angle that we see. And once again, in each of these, you see a little swoopy thing on certain angles, kind of like we did on the first page. A right angle, that is going to be a square angle. Okay, if it looks like the corner that you would find in a square, and then they draw a little square in there, that is a right angle. Okay. Again, we'll talk more about angles later on, but that's what you need to know right now. If it's got that little box in it, just like I drew right here, it's going to be a right angle. Okay. An acute angle means it is smaller than a right angle, which means it looks just like there's a little bit less space than there is in that square. And with these ones down below, it's going to be pretty easy to tell whether it's smaller or bigger. And then the other one is an obtuse, which means it's larger than a right angle, which means the space in between that line and that line is going to be more than what it looks like in a right angle. Yeah. So let's show you what we mean by that. Number 7. Does that little angle right there look like it's smaller, has more or less space than what this one right here has? Or does it look like it has more space? Or does it look like it has exactly a square? Does it look like a square is drawn in? Well, it doesn't look like a square. It looks smaller than what a square would be. If we drew a square in here, it would be pointing straight up like that. It looks like it's smaller. So it's going to be what we call acute. And the way that I remember acute angles is I think, oh, it's so cute. It's so little and cute. Smaller than a right angle. That was weird. I know. I apologize for that. But that's how I remember. Again, the dumbest ways are the ways that are going to help it stick in your mind. But that's how I think of an acute angle. Oh, it's so little. It's so cute. It's so much smaller than a right angle. Weird as that is, it works. So that one is an acute, which is smaller than 90 degrees. This one right here, if we take this again and we draw a straight line up to make a right angle with that line and that new red line, does that look like it's more than 90 or less than 90? In this case, it goes beyond our red line, so we're going to use that obtuse angle right there. Number 9, hey, we have our box. They drew it for us already. That tells me it's a right angle. Number 10, same deal. They drew the box in there right away off the bat. So we know that one as well is a right angle. Sounds like there was just a weather alert that went off on my phone. Kind of scared me, not going to lie. Number 11. We have our angle right here. If we draw a straight line up and down to make it a 90 degree, does that look like it's got more space or less space than what our red line and that horizontal line are? Looks like it's less. Oh, it's such a cute angle. It isn't acute. And then number 12, we draw our straight line up and down once again. Right there between those two should be a right angle, but looks like there is more space in between, so that one will be an obtuse angle and an obtuse triangle. Hopefully that makes a little bit of sense. Again, we're kind of easing our way into the whole angle piece. Understanding angles, practicing angles, it's going to take some time, but we are easing into things. We're kind of talking about them with triangles here, getting some practice with them. Triangles are a very good way to practice angles, but we will talk more about them as time goes on here. But that is our triangle section right there. So hopefully this stuff makes sense. I threw a lot of vocabulary at you. We had equilateral, we had isosceles, we had scalene, right angles, acute angles, obtuse angles, and just the word angle in general. Okay, this is the first time that we really introduced that idea of an angle and what an angle actually stands for and what it is. But hopefully this all made sense. We will continue to talk about it in future videos. But for the time being, we're going to leave things right here. So thank you for tuning in, for watching this video on triangles. If this video helped you, if you found it interesting, if you found it helpful, if you found it enjoyable, any of those three, please drop a like, drop a comment, let me know. And the more feedback I get on these videos, the more helpful it's going to be when I make future videos. So I truly, truly appreciate any feedback that you've got. As well, if you are enjoying any of these videos, if you enjoyed this one or previous ones, and you have not yet hit that subscribe button, feel free to do so. I would truly appreciate that as well. And if you hit that bell icon, you're going to be notified when I upload videos. I am on a hot streak right now, trying to get a whole bunch of videos up so that you can check these out. As we head into summer, I want to get a whole bunch of stuff up for the fall that will hopefully help anybody that's in school, any parents, any kids that are looking for a little bit of help on some of this trickier stuff. Math is a tough subject for a lot of kids and a lot of parents. So hopefully these videos are going to help you heading into the fall and if you're working on anything over the summer. But thank you for watching. I hope you have a great rest of your evening or afternoon or day whenever you're watching this. And stay tuned for the next video on quadrilaterals. Thank you and take care.